Alright, here we find ourselves in the last section that we need to cover before exam 2, section 7.3, which is solving trigonometric equations. Sorry, I'll pronounce that correctly. And so all you're going to see here is equations that we need to be solved, and we'll give all the solutions for them. This should be a reminder of what you did in trigonometry, probably over 2 sections, and they're just combining it here into one. Most of the problems will have limited outputs. What I mean by that is only asking for outputs between 0 and 2 pi, but others will ask you to provide a formula in order to generate all the solutions and possibly show like the first 6 or so, I think has been the standard there. So let's take a look at what type of problems are in here. So as I looked at the homework, the first style of problem that I saw was there was just a very basic one, just to make sure we're okay. Again, it's asking for answers between 0 and 2 pi. Pretty much everything is in radians because that's what we use in calculus, because radians are real numbers, degrees aren't. And so we usually use the radian measures because of that nature. So you know what we're going to do here. If we're solving for a variable, we isolate that variable or the function that variable is on, in this case sine. So we'll move over the 5 and get 4 sine theta is equal to negative 2. We'll divide by 4 and get sine theta is equal to negative 1/2. And then we just ask ourselves, well, where is sine theta equaling negative 1/2? Only between 0 and 2 pi. Well, it's going to happen twice, right? We remember that all students take calculus, so it's going to be a third and fourth quadrant angle. The third quadrant angle will be a pi over 6 angle, so let's say 7 pi over 6 would be one of the answers for theta. And then another one would be, in the fourth quadrant, 11 pi over 6. Now you can't call it negative pi over 6 because that's not in the desired range of values. You put it as negative pi over 6, it absolutely will be marked wrong and stay marked wrong. If they're asking for solutions between 0 and 2 pi, you can't give a negative number because that's not above 0. So make sure you give the outputs that are in there. There's an infinite number of answers to this equation. And yes, negative pi over 6 would solve that equation. They're asking for the ones that are specifically from 0 to 2 pi, and that's what we're going to give them. Awesome. So that's the kind of the basic one. Stepping up a little bit, and we had these that should be familiar, where all of a sudden something's squared. Shouldn't say all of a sudden, but we have something squared in there, so you know what to do. Isolate the variable term, and we get 9/12. So let's reduce that 9/12. So can 9/12 be reduced? Yeah, a 3 can go into each one of those, and we get 3/4. Awesome. Now we're going to take the square root of both sides. So let me do that in a different color. Take the square root of this side and the square root of this side. Now the most common mistake is a mistake that is made in beginning algebra when we're solving square root equations, and it's coming right here. It's to forget your plus or minus. So don't forget your plus or minus, because they're both there. So now we have cosine theta is equal to plus or minus the square root of 3 over 2, and we just ask ourselves, okay, and again, this is from 0 to 2 pi. Where is cosine theta positive and negative? In every quadrant. When's cosine theta, what angle gives us a root 3 over 2 when we take the cosine of it? Pi over 6. Right, the sine of pi over 6 is 1/2, so the cosine of pi over 6 would be root 3 over 2. And so we have the first quadrant angle, the second quadrant angle, the third quadrant angle, and the fourth quadrant angle. And we're done. Just naming those guys. And so ideally it's like that all those special angles are memorized. You can see that it would be a problem if you needed to refer to a calculator or something in order to get that from an efficiency standpoint, because again, this will be part of a larger problem. We do want to remind you how to do ones like this third one I'm going to do, sine 2 theta is equal to negative 1/2. And so this is from 0 less than or equal to theta less than 2 pi again. Well, remember what 2 theta does. It changes my period. The period is changing from 2 pi to pi. And therefore, between 0 and 2 pi, this thing's going to cycle twice. So we're going to get twice as many answers out of this. And so what do? Well, we ignore the fact that it's 2 theta. We don't ignore the fact. We treat the 2 theta as a group. And one of the suggestions is to say, okay, when does 2 theta equal negative 1/2? And so what we recognize is that we'll have double the amount of solution. So we're going to put, remember before, we might have had the negative 1/2 before. We did. We listed out 2, and we're done because that exceeded, if we were to list another one, it would exceed the domain, the desired range output. And so here 2 theta can be equal to, like we said, a 3rd quadrant angle or a 4th quadrant angle, right? Or a 3rd quadrant angle again. So we're going to extend ourselves out. Again, why are we doing that? Because we've with the 2 in there, we get double the outputs because we've cut our period in half. So in order to get the next 3rd quadrant angle, I would add 2 pi to 7 pi over 6 and get 19 pi over 6. Let's make sure I'm thinking about that right. 7 pi over 6 plus 2 pi later, well, over 6 would be 12 pi over 6. That's where I'm coming up with 19 pi over 6. And if it was 11 pi over 6 plus 12 pi over 6, that's 23 pi over 6. And you think, well, Jensen, why are you doing this? Because you went through and you graphed it. You knew it was going to repeat twice from 0 to 2 pi. What's it? Sine 2 theta. You knew sine 2 theta was going to repeat twice in there. And so you're going to list out twice as many answers because your job wasn't to solve for 2 theta. Your job is to solve for theta by dividing everybody by 2. 7 pi over 6 divided by 2 puts a 12 on the bottom. And this nice is how we want it. So it should be a nice reinforcement. Now take a look at 23 pi over 12. Where is it? Just below 2 pi. It's perfect. These are 4 answers that are all between 0 and 2 pi. All of them need to be stated. And so that's why they're asking for that limited output. There are a few, maybe 2 or 3, that ask you to give all the solutions. So we want to model that. So this one says solve cosine of theta over 2 equaling negative root 3 over 2, identifying giving all solutions in the real number system. So we know there's a bunch, right? We always knew, even back here, that there were going to be a bunch of solutions, more than 2. There's, for example, negative pi over 6, even the 19 pi over 6 would work. And so they're very easy to get. We just recognize that they're always 2 pi later. So again, what do? We just roll with the theta over 2. And we start talking about when in the first period of this, when between 0 and 2 pi, do we get solutions? Well, root 3 over 2 corresponds to a pi over 6 angle. It's negative, so it's got to be a 2nd quadrant angle, 5 pi over 6, because cosine's negative in the 2nd quadrant. And theta over 2 could also be equal to 7 pi over 6, another place where cosine is negative, right? That 3rd quadrant. So we get 2nd and 3rd quadrant angles. Now, where are all the other ones? They're all 2 pi later. And they use a k in our book. Sometimes they use an n, but most are using a k. So remember, that's how we got these other ones. We got 7 pi over 6, but we added 2 pi in order to get 19 pi over 6. And we added 2 pi to the 11 pi over 6 to get 23 pi over 6. Now we're almost done, The reason why we're not done is because they've asked us to solve for theta. So what do we have to do to solve for theta? We multiply both sides by 2. And everything gets multiplied by 2, every term. So now I get theta is equal to 5 pi over 3 plus 4 pi k. And theta is equal to 7 pi over 3 plus 4 pi k. Now why 4 pi? Remember what just happened with the theta over 2. We stretched out our period. Our period is now 4 pi for that one. And so that's why they have us do the graphing first. So these types of results make a whole lot of sense. Oh yeah, this thing's repeating itself every 4 pi now. We don't have to take that into account right away. We can just let the algebra naturally dictate that to us. And we have these answers right here. So really good math in there. There is one other aspect to this problem. They wanted us to list out the first 6 answers. So obviously the first 2 are already there. 5 pi over 3, 7 pi over 3. The next one is 4 pi beyond 5 pi over 3. So 4 pi is 12 pi over 3. So added to 5, we would get 17 pi over 3. 12 pi over 3 added to 7 pi would be 19 pi over 3. And then I would add 12 pi over 3 to 17 pi over 3 to get 29 pi over 3. And 12 pi over 3 to 19 pi over 3 to get 31 pi over 3. Those are the first 6 answers. Again, all we did was follow what's above. Hey, I need to take 5 pi over 3 and add a 4 pi to it. Oh, no problem. 4 pi is 12 pi over 3, and that's where these are coming from. That's why I keep talking about 12 pi over 3. But you probably already got that from my wording in there. So that's this, like part 2 of the question would be to list out the first 6 answers. So really good problem in there. They will have some that are algebraic in nature, where you, just like they did in your previous classes, where you have to solve a quadratic. So one that I saw in there was 7 sine squared theta plus 15 sine theta plus 8 is equal to 0. They'll keep them where they're factorable, right? We see the factorization here. It's the 7 sine theta times sine theta, the 8 here, the 8 here, right? So that we get an 8 plus 7. Move that 8 and a 1 here. Now I got a 7 sine theta and 8 sine theta. That's going to give me the 15. They're both plus, and that's equal to 0. And what you have are basically really quickly 2 small equations to solve. When 7 sine theta plus 8 is equal to 0, or when sine theta is equal to negative 1. Well, this would be when sine theta is equal to, we take it in stages. 7 sine theta is equal to negative 8, so sine theta is equal to negative 8 sevenths. Well, when is sine theta ever equal to negative 8 sevenths? Never, because that's over 1. And sine theta only has outputs between negative 1 and 1, so there's no solution coming out of this one. Now out of this one, when is sine theta negative 1? Well, that's going to be on either pi over 2 or 3 pi over 2. It's going to be at the 3 pi over 2 because it's negative, right? So we get that really quickly by knowing our quadrantal angles is what they told us. It's usually the first thing that they cover in a trig class when they've introduced sine and cosine. They'll talk about what's at 0, pi over 2, pi, and 3 pi over 2. And so only one solution for this one, 3 pi over 2. It's the only thing that works. They do have questions like this as well. This is the last one that we'll do together. This might throw some off. Tangent theta is equal to negative root 2 sine theta. So there's nothing magic that we can do here. I mean, we could start changing tangent theta into sine theta over cosine theta, but I'm not sure how much that helps. What if we just thought through it? Remember that sine theta and cosine theta share the same 0. And so those have to be solutions. So 2 of the solutions, just by knowledge that they're the same at 0 and at pi are already here, right? The other question comes when the relationship between tangent and sine theta is a negative root 2, like um, what do I want to say like a proportion, but a ratio of them would probably be a better statement. So remember, tangent theta divided by sine theta would need to be equal to negative root 2. Well, what is tangent theta divided by sine theta? Well, tangent theta is sine theta over cosine theta divided by cosine theta. Okay, now I didn't want to do this first because the moment I start manipulating this, I'm going to lose a solution, but I'm focused on this negative 2, so it's important that we see the 0 and the pi first. So, apologize, not divided by cosine theta, divided by sine theta. Okay, so let me relate these. So if that threw you off a little bit, didn't mean it to, we know about these relationships, we might as well use them. There's other ways to talk yourself through it, but I'm going to, whoops, meant to get a highlighter there. I'm just going to highlight tangent theta and highlight tangent theta down here. Well, if we look at that division, obviously that division is just 1 over cosine theta equals negative root 2. Let's flip both sides, right? Let's take this to the negative 1 power and this to the negative 1 power, and we get cosine theta needing to be equal to negative root 2 over 2. And we're going to solve from there. So let's make sure that those intermediate pieces make sense. So did you follow how we came from here to here? Well, we have sine theta over cosine theta divided by sine theta, which is sine theta over cosine theta times 1 over sine theta. And now your sine theta is canceled, and you can see exactly why we went to 1 over cosine theta. Let's make sure another piece is okay. So we really feel like your math's getting more and more sophisticated, and you want to challenge yourself to have it be that way because you chose a very sophisticated major, right? One that would have you think like this. How about the negative root 2 to the negative 1 power? Did you follow that? You know that anything raised to the negative 1 power is 1 over that thing. You know that you can't have a square root in the bottom, so you rationalize it. And you realize, oh, this is just negative root 2 over 2. Well, where's cosine theta negative? Well, it's negative in the second and third quadrant, and we know it's a pi over 4 angle that gives us that. So we get 3 pi over 4 and 5 pi over 4, and we're finished. So we can do these, right? It just takes some creative thinking. These are not necessarily creative thinking. This is bringing our algebra skills along with the core aspects. These are helping us, 4 and 3 are helping us remember the period adjustments that are there and expecting how many solutions. So it's all just designed to help. Here we're remembering that when you take a square root, you need a plus or minus, and these are just our basic core ones here, right? This number 1. So everything's being reviewed, and obviously it will be on the test. They're important skills to take forward with us into other math classes.